So now let's take what we've just learned and let's apply it to a bigger problem, one that we wouldn't want to find the individual probabilities for because it's just too large. All right, I drew in a couple visuals for us. This is the same probability experiment that we talked about a few pages ago. You have 53% of people had coronary bypass surgery in 2008 were over the age of 65. 15 random coronary bypass patients are sampled. Find the following. So remember, we learned a couple pages ago that this is binomial, or this is a binomial experiment, where n is 15, p is 0.53, q, which is the 1 minus p, is 0.47, and then x can be anywhere from 0 to 15. Now you can already see that this is a more complicated problem because we're talking about 15 people. It's not talking about 3 free throws, if you will. It's talking about 15 of them. This is so complicated, you wouldn't want to make a tree diagram. You wouldn't want to use brute force to find these probabilities. You want to be able to use the binomial aspect of this to find some probabilities for you. And I drew a little visual over here just so you could get a sense of what was going on. So I want to start off with my first one. I want to find the probability that exactly 9 of the patients are over the age of 65. So that's this little value right here that I'm talking about. Exactly 9. Okay, so if I want that exactly 9, I'm going to have to use binomial PDF, because remember, binomial PDF talks about exact values. So if I want the probability that x is equal to 9, I'm going to have binomial PDF, and then it's n comma p comma x. So n is 15. We've determined that already. There's 15 trials. You're looking at 15 random patients, right? So n is 15. The chance of success is 0.53. There's your p-value. And I want exactly 9, so that's why I have 9 right here. All right, now I'm going to grab the calculator, and I want a PDF value. So I'm going to go to second distribution. There we have it, binomial PDF. And I want to say 15.539, paste. And it's 0.1780. All right then. Now let's talk about the probability that at most 6 of them are over age 65. Now, at most is a little bit of a phrase that's kind of strange in English. If you think, I want at most 2 children, that means at most. I don't want any more than that. I want 2 or less, right? So that's what you're saying. So when you say I want at most 6, I want 6 or less, right? And that's the English for it. So 6 or less would mean that you want all of these ones right here. So let me highlight them for you just so you can see it. So 6 or less is right there in green, okay? So if that's 6 or less, how do I get that? Well, you'd get that by taking binomial CDF. You want it to accumulate. It'll start at 0 and it'll add up until you tell it to stop. And you want it to stop at 6 because you want to include 6 here. So you can see I've already found it, but let me find it again for you. So you say second distribution is binomial CDF, and you'll say 15.53, and I want it to stop at 6. Enter. And then I get 0.2265, and that's where I got that result from. So I didn't actually have to find any of these individual probabilities, right? Think about what that means. There's 7 probabilities in here. You could find all 7 of them using the rules that you use for letter A, but why would you want to if the calculator is going to add them all up for you? Why not just use that fact? Nice, huh? I mean, you pay good money for the calculator, you might as well use it, right? All right, now what about the probability that fewer than 8? Fewer than 8 would be 7 or less, right? So if I'm going to unhighlight a little bit. All right, fewer than 8 is 7 all the way up to here, right? Less than 8, that's what you're saying, right? Less than 8, which is 7 or less. So let me write that up. All right, so that's binomial CDF 15, 0.53, 7. You want to stop at 7 because you want less than 8. 8 isn't less than 8, so you have to stop right here at 7. All right, so let me grab the calculator. I'm going to teach you a little trick here. See how everything I've typed in is what I want? I just want to change the 6 to a 7. If you hit second enter, it'll give you your last entry, And you can kind of move over with your arrows and change the 6 to a 7 and press enter. And it will find that probability for you. It just keeps you from having to go back to the distribution menu every time if you don't want to. I mean, you can, you still could do it, but why bother, right? All right, so we get that these probabilities that are kind of highlighted by my mouse right there would all have added up to 0.4065. All right, now let's do a tricky one. So I gotta undo my highlights 1 second. I want the probability of at least 5. At least 5. So 5 or more, that's what at least 5 is. Means, you know, if I want at least 5 correct on my next test, I want 5 correct or 6 correct or 7 correct, right? So that's a little bit complicated because the binomial distribution only finds less than, the cumulative part. So you say, look, if I want at least 5, that's what I highlighted in yellow. So I want the probability of 5 or more, which is x is greater than or equal to 5. So what I'm going to do is I'm going to take 1 minus the probability of x is less than or equal to 4. In other words, instead of finding this yellow region right here, I can't use binomial CDF to find that. Binomial CDF always starts at 0 and adds up until you tell it to stop. So if I'm going to start at 0, what I'm going to do is I'm going to say, look, take 0, add it all the way up to 4, find those probabilities. And then I'll just take it away from 1 because I know that the whole column over here has got to make 1. That's a rule of probabilities that I learned in chapter 5. So I'm going to find the probability that x is less than or equal to 4, and I'm going to take it away from 1. That's 1 minus binomcdf. 15 is still your n, 0.53 is still your probability of success, and 4. You're adding up these probabilities all the way up to 4, and you're going to take it away from 1, and it'll give you what these yellow ones would have added up to if you went and found them. So you can do this all at once, or you can do it in stages. So I'll do it in stages. So I'll say second entry again. I'm going to change that binomial CDF from a 7 to a 4. That gets me 0.0363. And then I take 1 minus second answer. 1 minus that answer, enter. And it gives me 0.963676. So 9637. I'm being silly. And that's the result right here. All right, to keep our sanity, let's stop right there, and I'll have to do these last 2 parts in the next video. So I'll see you back here for that part.